Welcome to the 25th episode of Randomly Typed.
Howdy, folks.
I'm JS.
I'm Cowboy Lance.
So, Cowboy Lance, what are we talking about today?
Let me ask you a question first, if that's all right. Do you
That's all
accept
right.
me asking you a question?
I totally accept your question.
Regardless of what the question will be?
Yes, but I might not give you an answer.
Oh, okay, cool. It won't be too offensive.
Okay.
Jess, do you know what CRUD is?
CRUD.
That's right.
Right. Create something, update, delete.
Create, read, update, delete. So what is CRUD?
For actions.
What do they mean and what do they represent?
A list of actions you normally can do on resources.
Right. So it's a conceptual model for operating on like piece of data, like a record, let's say. You can like create a record, read a record, update a record, delete a record.
Right.
A lot of applications are centered around this model because it's very conceptually simple, right? Kind of maps to the real world very well. And that like you can represent this object, like this object here can be created, read, updated, and deleted, and it is a single thing, right? Do you like using CRUD?
I guess so. I never thought about it. I just assume it's there.
Have you ever been in a situation where it's been really difficult to design your application because of CRUD? Because of kind of like the assumptions that people make using CRUD?
I'm not 100% sure where you want to go with that, but I feel like sometimes it's too simplistic for what you want to map.
That's exactly where I was trying to go. So oftentimes, if you stick rigidly to CRUD, you'll end up in situations where it might not cleanly map to what you're trying to represent, what kind of like business models you want, and just general like flows you want in your application. So today we're going to be talking about something called CQRS.
Sorry, say that again?
CQRS. I think most commonly it's enumerated as CQRS.
All right, that makes sense.
Does it though? Do you know what those things stand for?
I mean, it doesn't. So when you enumerate it, it doesn't sound like shit. So,
so CQRS is something called Command Query Responsibility Segregation.
Oh God,
I know, right? All design patterns have very crazy names. So at its simplest, what it represents is taking the R away from CRUD, separating the R from CRUD so that it becomes R and CUD. What that means is that an individual model can have independent write capabilities from its read capabilities. Why do you think that would be useful?
I'm really not sure of what you're saying. CRUD is for different actions.
Right.
So you're saying here that you're removing the read part of it?
Yep. Let's say you have a penguin model in your application. You're trying to model the world of penguins. You can, in normal circumstances, create, read, and update and delete a penguin, which is very unfortunate.
Yes.
So if you're going by CQRS, you would have one model, which represents the ability to create, update, and delete penguins.
But not read it.
But not read it. If you want to read it, you need a separate associated model, like it's related, but you need to interact with a completely different service or a completely different object to be able to read the information that was written to.
Right, I see. So you separate the concern of writing and saving data from using the data.
Yes, exactly. This pattern allows for defining how you read things in a way that's very different from how you might update it. If you're using CRUD, you kind of assume that you have a single model and that whatever you write to can easily be read, or whatever you read from can easily be written to.
Right. The written data and read data is really similar.
Right.
Or they're exactly the same, in fact.
So in 99% of cases, this is probably a good assumption to have. In the 1% of cases, though, it's not necessarily true. You're kind of like taking away from the performance or access patterns or interface of the updates by forcing the read into there as well. So other than that, can you think of any other useful reasons to do such a thing?
All right, I think I see where you're going with that. So I feel like you don't always consume the data the same way you want to write it. So for example, you might take a census of your penguins, but when you read it back, you only want the final stats of it. So you don't necessarily read the same format as you wrote.
Absolutely. That's actually a perfect example. And like, let's say you weren't a statistician, you didn't really care about stats, but you wanted the cuteness level. You could have a separate cuteness level penguin read service, right? One advantage of this is that you aren't locked into an individual model. You can have any number of read models because it's effectively independent from at least the interface for writing your data.
Here, when you say model, what do you mean? I feel like it's super specific to one type of code base, but is it what you're saying?
I'm not necessarily one type of code base. I'm thinking of it in like a domain-driven design way, like in a domain model, like some entity which represents a part of your application.
Okay.
But we'll get a bit more into that because that's often a very overloaded term.
Yeah, exactly.
And it usually has connotations of persistence, right? Like one model often is associated with a single database table and stuff like that, which is not necessarily truth, right? You might not want to do such a thing. That's basically it, actually. CQRS is just the concept of separating your read patterns from your write patterns for a specific domain object. It has a bunch of nice reasons for doing it in that you could have multiple different read patterns. You're not necessarily compromising the interface of your read because of your write patterns.
Right, because like in CRUD, most of the time it will be exactly the same interface. So
right.
Like you need to write this byte there and you'll get exactly the same byte.
Right, you're kind of forced to in that like...
You get the worst of both schema.
Exactly. Whereas if you separate them, it's going to be more complex, but you can enable certain optimizations, define different access patterns. If, for example, you wanted to privatize some attributes that you must write to, but that you can't necessarily read, you can do that on a regular object as well, granted. But it's one less field you have to necessarily worry about, and that might enable you to do some super performant thing, right?
So do you have some concrete examples?
I do not. This is probably a bad idea to do, honestly. This is kind of more in the like advanced modeling stages. If you can, please use CRUD listener. It makes your life easy. But if you're struggling to write like some SQL query or something and it's just not working out, you can kind of frame it in a different way and be like, could I make this write faster if I didn't need to read from it again?
Yeah. For me, it sounds a little bit familiar with materialized views.
Exactly. So materialized views are very much in the same category in that they present an interface for reading that's different from how you write things, right?
For the listeners that doesn't know about this, what's a materialized view, Lens?
Oh my gosh, Jess, I'm going to have to defer that to you because I know that it is basically like a virtual... I mean, I'm totally going to grow... I'm unprepared for this question, but it's effectively like a virtual table that gets updated as other data gets updated. And so it can be read from, although it is kind of derived from information that's already there. And it's transparent to you as to how it gets populated, which is great because it's super convenient. But I also hear that it's a mess to optimize and that it's very difficult to know how this thing will perform in advance.
So here, a concrete example. Normally, when we talk about materialized views, we talk about SQL databases. For example, you have your Penguin tables and you have a materialized views, which would be the statistics. So every time you update your Penguin table with the specific data, your materialized view get updated. Once you want to read the average age of your penguins, the data is already pre-computed for you and there.
That's it for CQRS. It's relatively simple of a concept and it's super applicable. Most people probably do this without knowing. The reason why it has a name and the reason why it's, I guess, somewhat popular is that many people take it way too far. And by doing that, I don't say too far. It probably works well for their use case, but this can get complicated very quickly. As you can imagine, reads don't necessarily need to run on the same physical server anymore, right? You can abstract that out to a different process, to different computers. It could be a distributed system now, right? You don't necessarily need for it to be co-located with your writes at all. They're completely independent now. You can go even further and be like, well, I don't want this to be associated with the same database table anymore. If you're reading from a different table, of course, you would need some way to like propagate changes from your write table to your read table. You could also just do it as like a reporting database. So like if you have a replica or of some sorts and you can perform transformations on it, sort of like a materialized view, right? You can, materialized view would be in the same database, but I guess
I don't think it needs to.
Yeah, but like those possibilities suddenly open up to you. And now you've got a distributed system, and now it's a mess.
So are you saying that distributed systems are a mess?
They're much more complicated to deal with than non-distributed systems, right? You don't have to deal with time. You don't have to deal with ordering in a non-distributed system. So please CRUD unless you absolutely have to. That being said, it does allow you to do some pretty cool things like scaling independently, optimizing for different access patterns, like only exposing the interface that's necessary if all you want is statistics.
I feel like your point about the fact that you can optimize for different access queries is really interesting. Because again, with the statistics for the penguins, once you pre-calculated all the statistics, it's instant to get, which normally could take, I don't know, minutes, hours, if you have a lot of data.
Yeah, absolutely. Then again, it gets more complicated again because you need to pre-compute that and then store the results somewhere, right? It's no longer a single spot that's being shared by all operations, but that's something that's totally doable. You can do validations in the background. You can depend on multiple models from your reads. You could compose multiple writes into a single read. You can do lots of different things here. So why wouldn't you do this?
Well, you just said it. It's complicated.
Yep. It's complicated. There's a lot of maintenance. There's definitely overhead. As a new programmer coming to a new code base who's used to CRUD and the simplicity of CRUD, it's difficult to get used to. And that suddenly there's a bunch of different models and processes and workflows and tasks and services you need to think about. Also, if you're using different tables or different databases altogether or different web servers completely, you end up in a distributed system, and now you can't rely on your database to provide consistency for you, like ACID guarantees for you. So you often see this when you're looking at eventually consistent systems or event-driven systems. This is like a nice way to form different optimizations and perform these sorts of abstractions without necessarily relying on one individual table and the consistency that it might provide. So I mentioned eventual consistency. That is pretty new stuff in the world of databases, in the world of distributed systems. Let's talk about it in a different episode.
I think that's a fair point.
And that these systems are usually highly available, but they have different constraints, and you can't assume the same things anymore as that you could assume with individual database node.
Yeah, on one computer.
Right. And we did have an episode on kind of distributed systems 101 a while back. So it might be time to revisit that sometime soon.
Yeah, we really need to follow up on those subjects.
Yeah, that was kind of just like a whirlwind tour of like just the general concepts. It would be nice to do something like consensus protocols or all of this hot newness, all the microservices, all the Kubernetes, what all this stuff means. The 12-factor app could be interesting.
I have no idea what this is.
Oh, okay, cool. Maybe we can make that the next episode.
All right, cool.
So that's all I had today. Today's a short one. I find if you stop looking at everything from a CRUD perspective, lots of opportunity opens up.
All right, that's a nice way of presenting this. Well, thank you, Lance.
Thanks, Jess. Thanks for listening to me ramble.
Let's ramble more on the next episode.
Excellent.
All right, see ya.
This podcast is both free and free, as it's distributed under the Creative Commons.
You can contact us and find show notes on our website, randomlytyped.com.
The intro music is by Vansky.
Thank you, Vansky.
And thank you, listener, for indulging us.